projection on the wall, where if you put bright colors, then on the wall they don't reveal. I think it's a really nice technology development. So my name is Lisa. I work for Aztec. Aztec is a private sale tool on Ethereum, but absolutely independently of like any blockchain. We also have Noir. Noir, we call it Universal Zero Knowledge Language. We started developing it approximately 4 years ago, I think. And today we released its Noir 1 point something, meaning that it's something that people pretty much already use for development of the real products. And by end of the year, it will only improve and improve and whatever.
It's my fault. Try now. Okay.
All right. So we say universal zero knowledge language. I guess everyone understands here more or less what is language, even programming language. Let's figure out what we mean by zero knowledge and universal. Aside of Noir or anything else, we have something we call zero knowledge. This is pretty much a protocol where you have two parties, prover and verifier. One party can prove something without, one party can prove something, another party can verify something without disclosing any information except for that something is true. In our case, we want to, in our case, we want to prove correct program execution on given inputs. Meaning that if the computer is executing some program on some given inputs, we want to get a proof, and what is important, we want to get succinct proofs, meaning that it's very small, that the program was executed correctly on given inputs. And then we want to be able to verify this proof in a way that it takes small amount of time. Something that smartphone can do. So zero knowledge language is a programming language that allows creating small proofs of successful program execution on given inputs. Before we came up with Noir, or any other company came up with any other zero knowledge language, we call it domain specific language because it's narrowed to zero knowledge. It worked approximately like, it was more manual, let's call it. If someone wanted to generate the proof of correct program execution, what they did, they execute the program. While the program is executed, they get the execution trace. It's pretty much the transcript of every operation that computer has done, like low-level operations like add, multiply, and all inputs and outputs. Then all this execution script that is usually quite huge, is encoded in some mathematical way, maybe like in polynomial or like vector commitment or something. And this was the whole this list that you execute the program, you take the execution trace, you encode it in some way, you make some math manipulations, you get it. And with Noir, it's pretty much you execute the program, then get the proof. Like you skip all these manual steps. And what it means practically for developers that they can use, they can write ZK programs without knowing cryptography behind it. Because of how the language is constructed, they write high-level language. In particular, it's Rust-based syntax. And when the program is executed, the proof is generated. Yeah, so Noir is universal ZK language. And why we say universal? Because it's not tied to pretty much to anything. It's even not tied to blockchain. In general, if someone has some product where they want to generate proofs and verify proofs, they can use it. Like in case of Aztec or like other blockchains. We do it on blockchain because that's how we prove the blocks. We put the proof on chain, and then someone can verify it. But in general, like if I'm generating the proof, and like someone is the verifier, I can just send the proof on WhatsApp if you want. And because of how zero knowledge protocol works, the thing is that if the proof is not correct, the verifier will never be able to say that it's correct. And if the proof is incorrect, the opposite is also not possible. But we still think about like Noir and blockchain context, and frankly speaking, today people who use it, they use it mostly in blockchain areas, but it's not limited to it. So Noir is universal decay language, Rust-based syntax, and it's domain specific. Yeah, so let's think we will do some demo and write some program and see like what is happening behind and how it works. Our plan is we will first just go through like all steps, and here there are like some code snippet, and then I will switch to the laptop and we will do the same, just like all the same steps but in real time. It's quite introductory, but I think it's a bit of fun. So we said that we have a prover and verifier. What we want to do. We have program that we will prove. We call it F. We have public inputs. We call them X and Y. We have secret input, W, and we have prover and verifier. So prover takes program, public input, secret input, and produces a proof. Verifier takes program, public inputs, proof, and returns 1 if proof is valid. So just as the difference, prover takes secret input, verifier doesn't take secret input, but it doesn't really matter. And in other words, prover is proving that it knows the secret W such that the program executed on like X and W equals Y. So how we do it, like, and like we want to prove something using Noir. For example, we will want to prove that we have two inputs, public inputs X and Y, and we want to prove that they are not equal. So what we do, we create a new project. It's like very general logic set. We create a new project. We write down what we want to prove. So what we will write down, that X not equal Y. Then we should put somewhere some inputs that we are proving against. And then we will need to generate the proof. And then we will need to verify the proof. That's pretty much it. So usually when we create the new project, we use, we have two files, one called src and one called nargo. And we usually work in the src file. There is inside it, there is something called main. We always, like in Rust, we always write code here. Oh, by the way, how many people know Rust? Oh, quite a few. How many people have ever written circum?
That's a bit more hardcore, I think.
Yeah, we do not need circum anymore. That is not so. So yeah, we have src file. We put our program, what we want to write to prove there. Then we have prover file. We put our inputs there, and then we have nargo file that's related to this presentation. When I think about what we want to prove, we said that we want to prove that X not equal Y. This is like typical Rust syntax, that you have main function. You give this function inputs. And then in the body of the function, we put like what we want to check, X not equal Y. What is specific for Noir, that by default, all variables are private. If we want something to make public, we should say this is public by adding like some credits pub. And then what we do, we generate a prover file. In prover file, we later will have proofs. And oh no, it's wrong. We generate prover files, and in prover file we will put our inputs, and then we compile and execute the program, and we get 2 more files. One of them contains witness, one of them contains compiled artifacts. Pretty much what is generated during while we compile and execute, we will give to the prover then to generate the proof. But this is like technical detail. In reality, you just copy the code and change the name of the project, and you know that the proof will be generated. This is just some. Yeah, and then we want to prove. This is how we generate proof. It says BB. BB is the particular proving backend that we use. So we say this proving backend. What we will do, we will prove. And then we point out exactly the files of witness that were generated on the previous step while we compiled and executed the program. And then we want to verify. To verify, we need to generate verification keys. So we will, again, we say VB, it's backend, proving backend that we use, we say VB, and what to do, right? Verification keys, and the same. And then we will verify the proof. And that's, I think, the point where we need to go to the another laptop. I hope I know it.
Can I ask a question?
Of course.
What is the meaning of the witness of it's using it? Why do we use a witness?
Yeah, you can think of the witness like when the program is executed, you still have the execution trace because it's like the computer that, like, you give it a high-level function, it deconstructs this function into simple operations and execute each operation. Mm-hmm. So your witness is pretty much how you arrived, like the description of how you arrived from inputs X, like, and Y, to the decision. In our case, that they are not equal. But because we want, I want us to, okay, well, let's do this way. Let's open editor. And let's open the page from where we will copy everything. And I will take the share. Okay?
Of course.
Yeah, so keep continuing to answer this question and then go to the code. But as we mentioned in the very beginning, we want the proof to be small, and we want the verifier to be able to verify fast. And this is provided by mathematical tricks behind all this construction, so that in fact, verifier could recalculate all of that on their own. But it takes like long time. Usually proving time is way longer than the verifier time. That's why this witness stays on the prover side, because prover doesn't care too much about heavy work. Maybe they have better hardware. It's designed this way. And verifier uses smart mathematical tricks without witness.
So it's like an aid for the prover. The verifier does not need it, and it is constant, or is it changing for every proof?
It is unique up to every program execution, because your witness will be like, you execute this program on these inputs, but it's deterministic. If you then execute the same program on the same inputs, you get the same execution trace. If you change the input, you get another one. Yeah, prover needs it to generate the proof, but verifier doesn't need it to verify the proof. It's a good idea. Wow. You know what I did today while preparing? I removed all pictures that I saved from the desktop, so that it looks.
You clean for Pesach.
Yes, exactly. So what we are going to do, maybe we are going to do here. Well, I have two. I'm good with one. Create a new project. Whenever we want to create a new project, we say nargo new and call our project. Of course, our project is called Hello World. Oops, it already exists. Okay, maybe we have to remove it first.
Sorry, it will be much easy to see if you a little bit zoom big.
Oh,
Command plus would do.
it makes a lot of sense.
Command.
Command plus would do. Yeah.
I will comment plus. Give me why? No, give me a second.
We have a lot of people coming with computers here, so.
I have a shortcut for
Nice.
plus
Yeah.
for make more.
Good.
Oh yeah. The money printer.
Yeah.
I can also maybe help you.
If you don't mind.
I will erase the entire folder, it's okay?
Yeah.
Hello world. How?
Just accelerated the work. So we want to make a new project. We make a new project. As we mentioned above, like our project looks approximately, there are two files, nargo and src. Nargo, we don't care today. Src is a file where we put our function. And whatever we want to prove, we will put it to the src. But also, I think we want to open it. And in this src, we have a file called main, and with the extension nr, that stands for Noir. And here we have a function that we want to prove that takes two arguments, x and y. One of them is private, one of them is public, because we added a prefix pub. And we want to check that they equal to each other. We want to create a prover file. We do nargo check. Now we also have a prover file, and it said that, okay, we have x and y. We need to put some values. We put some values. Now we need to execute and compile. We say nargo execute. And now we have also the folder called target that contains two files, one of which is witness, and we can't see it because its format doesn't allow us. And also another one, both of them we will give as inputs to generate the proof. And this is the next thing we want to do. We want to generate the proof. Of course, we don't remember it by heart. We just copy it from here. I will share all the links of like on tutorials and getting started and everything. We give it the command to generate the proof. And also, we say that we want to have this proof as a field element, not as bytecode. Yeah, so that we actually can see the proof. So it says like scheme we use is ultra honk. This is the proving system that by default is provided in Noir. And then circuit size is 18 gates, and then proof saved here. And we can see the proof. We have one proof as a bytecode, we can see, but also have proof written as a field element. It doesn't make too much sense, it's just numbers, but nice to see what is the proof, a lot of numbers. Then we want to verify the proof. To verify the proof, we need to generate verification keys. We can go to this lovely file and copy. We say, okay, VB, use Bartenberg, our proven backend, and write verification keys for us. And again, we want it in field elements so that we can see what in fact verification keys are. Oh. So we generated verification keys. We can see them here. It's also not very impressive. Mostly zeros, but sometimes it's not. There's like a lot of verification keys. Let's find something that is not zero. Oh, okay. And then we finally want to verify the proof. So we go back to our file. What? Oh, proof verified successfully. And pretty much that's it. To circle back to like when we pass all these lines of code of letters, we pretty much say VB, which proving backend we want to use, and then we say what to do, like prove or write verification key or verify, and then we pass the necessary files. In case with prover, we pass it where it was. We pass it generated witness. This is something with the extension JZ, as well as some generated artifacts that were generated during execution and compilation. And to the verifier, we pass only generated artifacts without witness. Now we can jump back to the So we did this one. Yeah, and then the question like, okay, we can like generate proofs, what we can really do with that. Well, okay, not what we can do. We do not know what we can do. What other people have done with that so far. One of the things written in Noir is ZK email. It allows us to generate proofs of something that has happened in the email and is signed. For example, if someone has insurance and got their bill for insurance and it says that you have a particular car, one can generate a proof of owning a car. Something like that. And what people make possible using ZK email, because ZK email, it is something that it's a library that allows you to generate proofs based on emails. So what people do with it, they for blockchain, it's like account recovery. They use an email for account recovery, ZK P2P, that is peer-to-peer payments, 2FA authorization, proof of Twitter, wallets based on email, like without any key at all, like key in the way that we see today. And like other fun things is ZK login, signing with Google and Apple ID.
Why it's different from any other tools of email like that I can just go to the court with your email, with all files that it has, like digging all of the things, and it's already proved to exist. Why you need to be blockchain for doing something about email?
It's not about using blockchain, it's about using zero knowledge proof for that. You can do it without blockchain. I think because zero knowledge proofs evolved a lot during blockchain, they mostly exist today within blockchain.
What really, okay, really be useful zero knowledge in the situation with email. Like if you go to the course, you definitely can. You don't need to be zero knowledge, and everyone who already a chain of this email, they already know everything about this email, and you have like real sites about everything. So
yeah, I think you can't bring ZK proof to the court today. It's true, but you can use it for like for proving authenticity of emails, because
again, it can be done with classical email nowadays. Every part of the chain can be defined.
you can change the I can change the front end on my side and provide it.
But you can change it so much. Probably it's not for sorry.
You can chat later about it.
Yeah.
Happy to. Yeah, other fun things, ZK login that allows to sign in with Google and Apple ID to like any blockchain dApps and services. Git claim, privacy preserving airdrop claims through proof of GitHub contributions. And on a DAO, privacy preserving verification of Indian residence ID. Nouns anonymous voting, the anonymous voting application for nouns, ZK passport, generating passport and national ID, like that someone is from a particular country or above particular age or something else. Stealth node, an application for people in organization to anonymously using Noir today in blockchains. We will need to verify the proof somewhere. It can be like, so if you write Noir, you can write it on obviously Aztec, that's you, and on Starknet, and on almost any EVM compatible chain such as Optimism between Polygon. If you want to use it for purely proving without any privacy, it works. If you want to use it for something private, it can be only something monolithically private, where you put on one hand inputs, then something happens, and you get outputs, meaning that you can't do something private, something public. The only place where you can do something private, something public is Aztec. Questions, how is it compiled from like how level program is what is happening. What is happening is that the Noir program is compiled into abstract circuit intermediate representation. This is some format that then potentially can be converted into any proving backend. Formally, we call it, oh yes, it's backend agnostic, it's true, and we say, oh, any backend. In fact, developing a new backend for a proven backend is quite a heavy job. So what we have today in Noir, it's ultra honk. It's something that Aztec Labs developed for last maybe 5 years, I don't know. But other teams, if they are interested to use Noir, but for some reason Plonkish arithmetization, this is in particular elliptical cryptography, doesn't work for them. There are teams who work on their own backends, for example, R1CS, if they want it for some reason. Yes, and this is just a lot of links. I think I will share this presentation in the chat. That just a quick start. That's something that we did today. That just how to install, how, all these things. Then there is a nice tutorial like how to build your first web dApp that allows to prove the age. And then there are Noir docs. Then there is also Noir repo that lists all resources, all libraries that we have, all projects that were built on Noir. Yeah, and then like if you feel like you want to do something with Noir, if you have any questions, like technical questions, the right place to ask them is on Discord, where like DevRel will answer you. If you want to study Noir and need some special vibes of learning, there is a special Telegram group for it. You should ask me for that. Is that the group where people vibe and share what they have learned and what doesn't work and what works and all things like that. And finally, we have something called Noir Hack. This is just 4 weeks online hackathon where people can build whatever they want using Noir. Yeah, it will include some learning sessions and some like hacking, but it's quite a freestyle format. And that's what I was like. If we have any questions except for emails.
In Silicon Web, you like the Silk